Welcome to Techie Wise. In today's video, we will be having a discussion on Chinese Reminder Theorem. So, what is the use of this theorem? It is used to solve set of different congruent equations with one variable but different moduli which are relatively prime. So, x congruent to a1 mod m1, x congruent to a2 mod m2, x congruent to an mod mn. So these are the different congruent equation with one variable but different moduli, right? So which are these moduli are relatively prime. M1, M2, Mn are relatively prime. Then using with the help of this Chinese reminder theorem, we can find the value of x. So how to find? So x is equal to a m1 m1 inverse plus a2 m2 m2 inverse. Like that it goes on till the number of congruent equations an mn mn inverse mod m. So using this, we can find the value of x. So here in this equation, you can see a1, a2, an are known variables. That is, it is given in this equations. Whereas capital M1 and corresponding M1 inverse, M2, capital M2, M2 inverse, and capital M, all those things we have to calculate. It is not directly given. Instead, we have to calculate with the help of all these existing values. So it will be clear for us when we see an example. We are going to consider two congruent equations. X congruent to 2 mod 3. X congruent to 3 mod 5. So how we can calculate it? So using the equation x is equivalent to a1. So here we have only two congruent equations. So a1 m1 m1 inverse plus a2 m2 m2 inverse mod capital M. a1 is 2, a2 is 3. And now, so here just we can make a note of it. a1 is equivalent to 2. a2 is equivalent to 3 and small m1 is 3. This is m1 and m2 is 5. So what is capital M1? Capital M1 is capital M divided by small m1. So what is capital M? Capital M is nothing but the product of all the moduli. So M is equal to M1 into M2. So M1 is 3 and M2 is 5. So it is 15. 3 into 5, that is 15. So small capital M1 is equal to capital M divided by small m1. So that is 15 divided by, what is small m1? 3. This is 5. So now we can compute capital M2, which is equivalent to capital M divided by small m2. So this is 15 divided by 5, which is equivalent to 3. Now we have to find the multiplicative inverse. So already we have discussed the extended Euclidean algorithm. You can use that approach or we can go for the trial and error approach. So what is, we have to find M1 inverse. What is M1 inverse? M1 multiplied by M1 inverse, we will get 1 mod small m1. So that is capital M1 is dependent on this M, right? So capital small m1. So this is 5 multiplied by something should be equivalent, congruent to 1 mod 3. So what is that something? 5 multiplied by 1, which is not congruent to 1. What about 5 multiplied by 2? 10. 10 minus 1 is 9, which is a multiple of 3. So M1 inverse is equivalent to 2. So now with regard to M2 multiplied by M2 inverse is congruent to 1 mod small m2. So what is capital M2? 3 multiplied by, we are trying for the divide and conquer, trial and error strategy. 3 multiplied by 1, so that is we are considering is whether 1 is M2 inverse. So we are trying that possibility. So 3 multiplied by 1 is 3. 3 minus 1 is not congruent to 1 mod. 3 minus 1 is 2, which is not a multiple of 3. Sorry, a multiple of 5. So now we are going to try it out with the 2. Yeah, 6 minus 1 is 5, which is a multiple of 5. So capital M2 inverse is equivalent to 2. Now we are done with the task. So now we can compute X congruent to A1 M1 inverse plus A2 M2 inverse mod M. What is A1? 2. Capital M1 is 5. M1 inverse is 2. Plus, what is A2? 3. Capital M2 is 3. M2 inverse is 2. Mod capital M is 15. So which is equivalent to 20 plus 18. So 38 mod 15. So X is equivalent to 38 mod 15 is 8. So X is equal to 8. We can try it out with one more example. 3 congruent equations. So X is congruent to 2 mod 3. X congruent to 3 mod 5. X congruent to 2 mod 7. So here we are going for equation is X is equivalent to A1 M1 inverse plus A2 M2 inverse plus A3 M3 inverse mod capital M. So what is A1? A1 is equal to 2, A2 is equal to 3, A3 is equal to 2, M1 is equal to 3, small m2 is equal to 5 and m3 is equal to 7. So capital M is equal to M1, M2, M3. So M1 multiplied by M2 multiplied by M3, which is equivalent to 105. So what is M? Capital M1? Capital M1 is equal to M divided by small m1, which is equivalent to 105 divided by 3, which is 35. And what about M2? Capital M divided by small m2, that is 105 divided by 5, which is equivalent to 21. M3 is equal to capital M divided by M3 is equal to 105 divided by 7, which is 15. Now the task is to find M1 inverse. So what is M1 inverse? M1 multiplied by M1 inverse. So that is M1 inverse. So 35 multiplied by something should be congruent to 1 mod 3. So here it is 2. So M1 inverse is 2. Similarly, here M2 inverse is 21 multiplied by something should be congruent to 1 mod 5. So what is that something? So it is 1. So M2 inverse is 1. What about M3 inverse? 15 multiplied by something should be congruent to 1 mod. So this is dependent on small m3, which is 7. So what is that? Again 1. So m3 inverse is 1. So now we can make use of this particular equation to compute x. So x is equal to a1. So what is a1? 2 m1 35 capital M1 inverse 2 plus A2, which is 3 multiplied by capital M2 21, M2 inverse A3, that is 2 multiplied by capital M3 15 multiplied by M3 inverse mod capital M, that is 105. So here x is equivalent to, that is 2233 mod 105. So x is equivalent to 23. So you can try it out for 23 in these equations. So 23, if what is that, if x is 23, yeah, 23 minus 2 is 21, which is multiple of 3. So here again consider this equation. 23 minus 3 is 20, which is a multiple of 5. 23 minus 2 is 21, which is multiple of 7. So here all these equations satisfies the value of x, which is 23. That's it with the Chinese reminder theorem. Thank you.